Hello everyone. In this video, we will be discussing about the voting. Mathematical representation of voting. It is the simplest way to combine the multiple classifiers. It involves taking a linear combination of the learner outputs. It's also known as ensemble methods or linear opinion pools. It helps to improve the classification accuracy by leveraging multiple models. In this equation, yi is representing the combined or the aggregated output for class I when multiple classifiers are used. So I represents the class. This wj, it represents the weight assigned to the classifier j. And dji, it represents the decision or prediction of classifier j for the class I. So yi, the aggregated output or the combined output, is equal to the summation of wj into dji, that is the weight assigned to the classifier j and decision or the prediction of the classifier j for the class I. So we are summing up the products for different classifier. J represents the classifier. Here, this wj should be greater than or equal to 0, and the summation of the weights that are assigned to j classifiers should be equal to 1. Here, this dji, it represents the decision or prediction. In case if the classifiers are providing probability estimates, this dji will be the probability assigned by the classifier j to the class I. In case if the classifiers are providing discrete outputs, then dji is typically 1 if the classifier j is predicting class I, otherwise it is 0. Classifier combination rules. We have the different rules. Sum, it tries to average all the predictions. Weighted sum, it includes the weight. Median, minimum of the predictions, maximum of the predictions, and product of the predictions. This is the sample data. We have 3 classifiers, C1, C2 and C3, and we have the predictions D1, D2, D3. So for each classifier, there are different predictions for 3 different classes here. So the corresponding predictions for the 3 classifiers are listed. As per the sum rule, it is the average of the 3 predictions. So for classifier C1, the average of 3 predictions is 0.2. C2 is 0.5, C3 is 0.3. We could find, as per the sum rule, classifier C2 is having the maximum value. Then finding the median, minimum rule, minimum of the 3 predictions here. So they are 0, 0.4 and 0.2 respectively. Then for the maximum rule, it's trying to give the maximum of the 3 predictions for each of the classifier. Then the product, it's a product of the 3 predictions. So here for the classifier one, there is a prediction 0. So finding the product, it is giving 0. As we could see, applying all the rules, classifier C2 is having the maximum value. This sum rule, it's commonly used and corresponds to averaging. It tries to balance all the classifiers. Median rule is robust against the outliers. Minimum, maximum rules are pessimistic and optimistic respectively. When I say optimistic, it tries to emphasize the strong classifiers. Product rule, it penalizes the classifiers with 0 output. So if any classifier has 0, the result is 0. Types of voting and classification. There are different types. Plurality voting, the class with the most votes wins. Majority voting, a class needs more than 50% of the votes to win. Weighted voting, classifiers are assigned different importance levels using the weights. Bayesian model combination, here we use the probability weighted decisions. The variance of the output y in an ensemble system is affected by the variance of individual classifiers and their covariance. This is the equation. So variance of y is equal to 1 by L square summation of the variance of dj plus we are finding the covariance between dj di. So now here this term summation of variance of dj, it's representing the sum of the variances of individual classifier. J represents the classifier. In case if there is a higher variance, it means that the classifier is less stable and it's more sensitive to variations. And this term, it's representing the sum of the covariances between the classifier outputs. So if classifiers are positively correlated, their errors are likely to be similar, reducing the effectiveness of the ensemble. At this term, this shows that increasing the number of classifiers reduces the overall variance. L represents the number of classifiers. That's going to reduce the overall variance. So when we are adding more classifiers, then the impact of individual classifier variance will diminish. Choosing an appropriate rule depends on the outlier sensitivity, correlation among classifiers, probability normalization. So ensemble methods like voting, it improves classification performance. Different fusion rules will have unique advantages and disadvantages. Weighted voting and Bayesian approaches, they offer probabilistic flexibility. Increasing independent classifiers reduces the variance and error. In this session, we have discussed about voting and the different techniques in voting. Thank you.